Today we will discuss the echo, reverberation, and how the distance of sound is measured in case of echo. So first of all, we have to understand what is the meaning of echo. So echo is basically what? It is also a reflection of the sound. It is based on the reflection of the sound. So basically echo is what? Reflection of the sound. And how, as you see in the tourist place, the echo points are marked. In echo points, what will happen when you speak loudly, you will hear back your sound after some time. So the sound is a reflection back into your ear and you will hear the sound. This is known as echo. Now, but how the echo is arrived, what is the conditions of echo, is we will see the different conditions. First of all, we see in the resolution of limit here the of sound. Resolution of sound is to hear two sounds as different sound. The time delay must be at least 1 by 10 seconds. So resolution of time is what? To hear two different sound, the time delay must be 1 by 10 seconds. To hear two different sound, the time delay must be 1 by 10 seconds. It is very important condition for getting the echo. Reflection should be at least the time delay 1 by 10 second, and that's why we say the resolution limit of sound is 1 by 10 second. So 1 by 10 second is what? Resolution limit. Now let us see some conditions, different conditions of when echo is formed. Condition for formation of an echo. Number 1, the minimum distance between the source of sound and reflecting body should be 17 meter. So we'll see how this is 17 meter. So minimum distance between source of sound and the reflecting surface should be 17 meter. Second condition, the wavelength of sound should be less than the height of the reflecting body. The wavelength of sound should be less than the height of reflecting body. Height of reflecting body. The intensity of sound should be sufficient so that it can be heard after reflection. The intensity of sound should be sufficient so that it can be heard after reflection, can be heard after reflection. So these are the conditions of the echo. Now let us see the how reverberation is generally occur in the big hall because reverberation is the multiple reflection of the sound. So generally waves reflect from the wall and travel back and forth. Means reflection, like when you see is in the cinema hall or any other place, you will find the shape is such that, so in the cinema hall, if one is your source and sounds are this way and reflected back, the person is sitting here. Similarly, the same sound can be heard by other reflection at any other place. So this you can see a small amount of vibration is desired in large hall or cinema, as it make the sound pleasant and more effective. However, too much reverberation is undesirable, as it makes the sound confusing. So it is now clear, reverberation means what? Multiple reflection. Multiple reflection of sound. When you want to reduce the reverberations, the roof and walls of the hall are covered with sound absorbing material like rough plaster or thin curtain. So when you want to reduce your reverberation, what you do? You will just roughness of the surface, then the sound is reduces. Now let us see some relations of between the sound and the echo and the distance. So let us relation between speed of sound, relation between speed of sound, time of hearing echo, time of hearing echo, and distance of reflecting body, and distance of reflecting body. So if suppose here is the source and this is your reflecting surface, the sound is reaches here and come back by this way. Suppose distance between them is d, is your distance between them, then the speed of sound will be, and the time is taken t after the reflection. So speed of sound v is equal to twice d upon time t. When you calculate the distance d between the source and the reflecting surface, will be d is equal to v into t upon 2. This is the distance between the speed of sound and the reflecting surface. Now, how to calculate the minimum distance? As we have discussed in the resolution of limit, the minimum time required to hear the next sound should be at least 1 by 10 seconds. So we will calculate, when we put the time t is equal to 1 by 10 seconds, we will get the distance as between the source and the reflecting surface. So t is equal to 1 by 10 second minimum time. Let us consider the speed of sound at room temperature is 340 meter per second. We'll put the values in this B is equal to V into T upon 2. So D is equal to V is your 340 into time is your 1 by 10 and upon 2 is in the formula. So 170 and 0 and 0 cancel out. You'll get D is equal to 17 meter. So it is very clear, distance between the source and sound should be at least 17 meter, and if the sound distance is less, so minimum distance is 11 meter is possible for the echo. 11 meter is the minimum distance of hearing echo, is the minimum distance of hearing echo. Now, definition of different types of sound, we'll see audible, ultrasonic and infrasonic. We'll discuss this sound is also in previous lectures. Today is just brief discussion of the audible sound, and we'll discuss more about the ultrasonic sound waves today. So audible sound, as all of we know, is in the range of 20 Hz to 20 kilohertz. What? Range of 20 Hz to 20 kilohertz, and this frequency is sensitive for human ear. Sensitive for human ear. Examples are all whatever we see is the example. Let us see some example. Sound of sitar, guitar, organ pipe, flutes, shehnai, etc. Sound wave produced by vibrating sitar, guitar, organ pipe, flute, shehnai. These are some musical instruments, and these all produce different types of frequencies, etc. Now we'll discuss the another forms of sound is ultrasonic waves. Wave. It is the longitudinal waves whose frequency is above the upper limit of audible range 20 kHz, greater than 20 kHz, and the waves are longitudinal waves. Now it is generated by very small source. We'll discuss these waves just now. One more waves as we know is what? Infrasonic wave. Infrasonic waves where the frequency below the audible range frequency less than 20 hertz. This is the range and it is generally generated by large source. The ultrasonic is generated by a small source and this is generally generated by large source. So let us discuss about the ultrasounds and the application and properties of the ultrasound. Ultrasound. So ultrasound, sound of very high frequency greater than ultrasound, as all of you know, the wave greater than 20 kilohertz. The production are produced by electronic oscillator using the high frequency vibration of quartz crystal. So production. These are produced by electronic oscillator are produced by electronic oscillator electronic oscillator electronic oscillator using high frequency vibration of quartz crystal, using high frequency high frequency vibration of quartz crystal, high frequency vibration of quartz crystal. Now properties of the sound waves, ultrasound waves, the properties of ultrasound waves. The properties of ultrasound wave. Sound waves of all frequency carry energy with them. With increase in frequency, vibration becomes faster and also energy content and force increases. When the ultrasound sound waves travel in solid, liquid and gas, it subjected the particles of the matter to face large force and energy. So what is the conclusion? Is here with increase in frequency, energy content and force is also increases. With increase in frequency, the energy contents and force is also increases. Increase in frequency, the energy, content and force is also increases. Now application of ultrasound. Application of ultrasound. Sound. First, welding metal. They are used for welding metals like tungsten, which cannot be welded and conventional by conventional methods. So one of the two piece of tungsten is held firmly against the other piece and then vibrate with the ultrasonic vibrator. The heat produced due to friction and the point of contact melt the metal. On stopping the vibrator, the melted end of the metal fused to form a tight weld. Next is very important is in medical purpose. Medical purposes. The ultrasonic vibration can be reflected from the boundaries between the material of nearly same density. The techniques used in scanning the internal organs of human body. It is superior to X-ray scanning as it does not cause any harm to human cells unlike X-ray. So it is very important. It is a substitute of X-ray because it is not any harmful as compared to the X-ray. The instruments which use ultrasonic waves for getting the images of internal organs of human body is called ultrasound scanner. In this technique, the ultrasound waves travels through the tissues of the body and get reflected from the region where there is a change in the density. These reflected waves are then converted into electrical signal. These signals are then displayed on TV monitor and can be printed on the film. Okay, so this is very important how the scanner, ultrasonic scanner work. Even the stones can be crashes due to this with the help of ultrasonic waves. Now, third, drilling holes on making cuts of desired shape. Drilling holes. This is also the same phenomena as we discussed. The ultrasonic vibration produces in a metallic rod called a horn. The horn acts like a hammer, hammering the plate about 100,000 per second. The plate about 100,000 times per second. The shape of the hole is the same as that of the tip of the horn. The shape of the tip can be designed as per the requirement of application. So next, for ultrasonic clinic. It is also very clear. Normally what will happen in the dirty cloth, it cannot clear easily, but for a small part such as those used in watches, electronic components, odd shaped parts such as spiral tube parts located in a hard to reach place, This method is convenient and sometimes possible. Next one is ultrasonic detection in the metal. Ultrasonic detection. So in case of ultrasonic detection, metallic components are used in building bridges, machines, scientific equipment and so on. These are cracks of holes inside the metal used the strength of structure and component is reduced. It can be failed such that such defects are not visible from the outside ultrasonic waves and can be used to detect. So this can be detected inside metal surface of defect in metal surface. Now example, bat fly in night easily because the bat produces a ultrasonic waves and this reflect by the surface, so it is very easy to fly in night. And this also search the insect by this method.